Good morning. Welcome to the next video. Today we are discussing about Regula Falsi Method, or it is also known as method of false position. There is a fundamental statement if the function f of x is equal to 0 is a function and a comma b are 2 points such that the functional value f of a into f of b is less than 0. That is, it may be f of a less than 0, f of b greater than 0, or f of a greater than 0, f of b less than 0. Then there exists a root in the interval a comma b. So here we are discussing about to find the roots of the algebraic or transcendental equation. If there are 2 points a and b, and if the functional value f of a less than 0, f of b greater than 0, or vice versa. That means f of a greater than 0, f of b less than 0, then there exists a root in the interval a comma b. So now the regular falsi method formula is x is equal to a into f of b minus b into f of a divided by f of b minus f of a. So now discussing about the problems, find the real root of the equation by the method of false position and correct to 4 decimal places. So the regular falsi method is also known as the false position. We need to find the real root. X into log x to the base 10 minus 1.2 is the given equation. So now we have to consider the given expression as the function of x. F of x is equal to x into log x to the base 10 minus 1.2. So now we have to give the values for x randomly such that the values must be, one value must be negative, another value must be positive. So that means the two functional values must have the opposite sign. So now putting the values for x randomly starting from 0. F of 0, if we put x value 0, we will get the value minus 1.2. That means we got a negative value. So now till we get the positive value, we have to give the values for x. So now putting x value 1. So here also we are getting the value minus 1.2. That one is also a negative. Now we need the positive. So therefore we have to give another value. That means x value 2. That is f of 2 is equal to. If we put x value 2, we will get minus 0.59794. That one is also a negative value. Next, we have to put x is equal to 3. Here we got the positive value 0.231364. So see here, f of 2 value is negative, f of 3 value is positive. So that means the root lies between 2 and 3. Okay, the values what we have substituted for x, that is 2 and 3. So for f of 2, the value is negative, f of 3 is positive, therefore the root lies between 2 and 3. So now let us take the 2 as the value a and b as 3. The smaller value we are always taking for a and the larger value for b. So now a is equal to 2 and b is equal to 3. So now substituting f of a, so f of a becomes f of 2, that is minus 0.59794. We have already calculated here, minus 0.59794. So and f of b, that means f of 3, that is 0.231364. Here we have already calculated that value, right? F of 3 is 0.231364. So now substituting in the formula x is equal to x1, that means the first iterative value for x, that is x1, is equal to a into f of b minus b into f of a divided by f of b minus f of a. So substituting the values, a value 2, f of b value 0.231364, b value 3, and f of a value minus 0.59794. If we substitute the values, we will get the value x1 is 2.721. Next, we have to calculate the functional value for this x1. That means f of x1 we need to calculate. So f of 2.721. The function f of x is x log x to the base 10 minus 1.2. We have to substitute x value now, 2.721. So we will get minus 0.701792, which one is the negative value. Now, this one is the very important step here. We have to choose the interval now. For choosing the interval, we must have a negative and a positive value. So here we got for 2.721, we have the negative value. So now we have to choose the positive value. So f of 2 is negative, 2.721 is also negative, so we can't choose those as the roots. So positive value is f of 3, that is 0.231364. So therefore, we have to choose 2.721 and 3 as the interval. So now the value of A becomes 2.721 and B value becomes 3. F of A is minus 0.017092. F of B value is f of 3, that is 0.231364. Substitute in the formula, same formula, x2 we mentioned because here this is the second iterative value of x. Now substituting the values, we get x2 is equal to 2.7402. Now check x1 and x2, there is a difference. So we have to do the third iteration. For that we need to calculate f of x2. That means here we got x2 2.7402. We need to use that one for calculating f of x2. Here we got f of 2.7402 is a negative value. So the positive value is f of 3. We need to choose f of 3 and f of 2.7402. So that means the interval is 2.7402 comma 3. Now taking A value as 2.7402 and B value is 3. F of A value is f of 2.7402. That becomes negative value minus 3.890457 into 10 raised to minus 4. And f of 3 is 0.231364, that is a positive value. Substituting in x3, we get 2.7406. So now compare 2.7402, here 2.7406. There is a small difference is there, so we have to do one more iteration. By calculating f of x3, we got to know that it becomes a negative value. So we have to choose with the positive value. So f of 3, that is 0.231364. 364 is the positive value. So the new interval is 2.7406, 3. Now A value is 2.7406 and B value is 3. Substituting in x4, we get x4 value 2.7406. x3 value is also 2.7406. x4 is also 2.7406. So comparing x3 and x4, we observe that the values are same up to the place of fourth decimal, and hence the approximate root can be taken as 2.7406. That means the last iterative value is always the best iteration. So we have to consider the last iterative value. So that means the fourth approximation, 2.7406 as the final answer. Now the second one, the expression is x cubed minus 2x minus 5 is equal to 0. Here we need to correct to 3 decimal places. Consider the given function as f of x, x cubed minus 2x minus 5. Give the values for x randomly such that one value must get negative and another value must be positive. So putting x value 0, we get minus 5, that is a negative. F of 1, putting x value 1, we get minus 6, that one is also negative. So therefore 0, 1 is not an interval. We have to consider 2 now. X value 2, that becomes f of 2 is also negative. So 1, 2 is also not an interval. We have to put x value 3 now. So then f of 3, that becomes 16. Here we got the positive value. So therefore the interval must be 2 comma 3. Hence the root lies between 2 and 3. Now taking a value 2, b value 3, f of a is f of 2 that is minus 1 and f of b is f of 3 that is 16. Substituting in x1 we get 2.05888. So now we have to calculate f of x1. Here we got the negative. Positive value is f of 3, so we have to choose f of 3 that is 16 as the positive. Now the root lies between 2.0588 and 3. Now we have to consider a as 2.0588 and b value as 3. So a is equal to 2.0588 and b is equal to 3. We get x2 is equal to 2.0813. Now again there is a difference, 2.0588 here 2.0813, difference is there. So you have to do the third approximation. For that you have to consider f of x2. F of x2 value is a negative value, so therefore consider 2.0813 and f of 3 that is 16 is the positive value. Therefore the root lies between 2.0813 and 3. So we have to consider always a positive with a negative value. So a value is 2.0813, b value is 3. So x3 becomes a into f of b minus b into f of a divided by f of b minus f of a. After substituting, we get the value x3 is equal to 0.862. So we have to repeat the same process. Repeating this process, we need to calculate f of x3 depending on it whether it is positive or negative. We need to choose the interval. Then substituting again in the formula, we will get x4 is 2.095915. Similarly, x5 2.0934, x6 is 2.0941, x7 is 2.0943. So here x6 and x7, the 3 decimal places are same. So therefore, we can consider the root as 2.094 is the final answer. Next one, this one is an important problem. Cos x is equal to x into e power x, and we need to correct to 4 decimal places. So when there is a functions of cos, sine, tan like that, we need to consider in the radian measures. So you people have to remember that. Let us consider f of x as cos x minus x into e power x, because the function must be in the form of f of x is equal to 0. So cos x is equal to x into e power x is there. So taking x e power x to the left, it becomes minus x e power x equal to 0. So that function becomes f of x. Now put the values for x. Putting 0, we get 1, that is a positive. Next putting f1, f of 1 becomes negative. So therefore we can choose 0, 1 and going to 1. We got one positive value and negative value. Now considering a as 0, b as 1, f of a is 1 and f of b is f of 1, that is minus 2.1779298. So substituting in x, we get x1 is 0.31467. So now we need to calculate f of x1. Here again we got a positive value. Choosing with the negative, that is f of 1 is negative. So minus 2.17798 is a negative value. Therefore the root lies between 0.31467 and 1. Now a value 0.31467 and b value is 1. Substituting in the same formula, we get x2 value 0.44673. Now there is a difference, 0.31467 and 0.44673. There is a difference is there. We need to calculate f of x2. Here we got the positive. Consider with a negative value, that is f of 1. So therefore the root lies between 0.44673 and 1. Then choosing a as 0.44673 and b as 1. Substituting x3, we will get x3 as 0.49402. Repeating the process, the successive approximations x4, x5, x6, x7, x8, and x9. So after the 9th approximation, we got 4 decimal places are same. So therefore 0.5177 is the final root. Next, discuss about f x is equal to tan x plus tan hyperbolic x. So we have here also we need to consider in the radian measure. So in the problem here they have given that a is 2 and b is 3. That means they will give the problem as find the roots of the equation tan x plus tan hyperbolic x is equal to 0 in the interval 2 comma 3. So therefore here we need to choose directly the roots as a is equal to the interval values a is equal to 2 and b is equal to 3. And we need to calculate the functional values, that is f of 2 and f of 3. Here we got tan 2 plus tan hyperbolic 2 is a negative value, tan 3 plus tan hyperbolic 3 is a positive value. So fundamental statement that also satisfies, that means one value negative, another value positive, so therefore the root lies between 2 and 3. Now considering a is equal to 2 and b is equal to 3 and f of a value point minus 1.221 and f of b value is 0.8525. So substituting in a into f of b minus b into f of a divided by f of b minus f of a, we got x1 value 2.589. Now we need to find f of x1, that is f of 2.589. We got a positive value. We need to consider with the negative value. So here the f of 2 value is negative. So therefore the interval between 2 and 2.589. So negative value. So the smaller value we are taking the value as a. So therefore a is equal to 2 and the larger value 2.589 becomes the value of b. So a is equal to 2 and b is equal to 3. Now we need to calculate the second approximation x2. Substituting the formula, we will get x2 value 2.4514. Again we need to calculate f of x2. So f of x2 value becomes positive. We have to choose with the negative value. That means f of 2 is negative. Therefore, the root lies between 2 and 2.4514. So now consider a as 2 and b as 2.4514. Substituting in x3, we get, after simplification, 2.3992 as the answer. So third approximation is 2.3992. So they have, I think in the question itself, they have asked you to calculate up to third approximation. So therefore, the third approximation is enough. If they have not given up to third approximation, we have to calculate the fourth and fifth and so on, so that the two approximate successive approximations must be same. Now use the method of false position to find the fourth root of 32 correct to 3 decimal places they have given. So now we need to find the fourth root of 32. So therefore, let us consider x as the fourth root of 32. That means 32 power 1 by 4 is nothing but fourth root of 32. Now rising the power of to 4, we get x power 4 is equal to 32. Now x power 4 minus 32 becomes 0. Now this is of the form f of x is equal to 0. So consider that as f of x, that is x power 4 minus 32. Give the values for x randomly, so that one value must be positive, another value negative, or vice versa. So putting 0, we get a negative. Putting 1, we get a negative. 2, we are getting a negative. Or 3, we got a positive. So therefore, the previous negative value is for x is equal to 2. So therefore, the root lies between 2 and 3. Now taking a is equal to 2 and b is equal to 3, f of a becomes f of 2, that is minus 16, and f of b is f of 3, that becomes 49. Substituting in x, 1 becomes 2.2462. Now calculate f of x1, that is f of 2.2462. Substituting in f of x, that is x power 4 minus 32, we get minus 6.5438, that is a negative value. Now we need to choose with the positive. F of 3 is positive, therefore we have to consider f of 3, that is 49 as a positive value. Now taking a is equal to 2.2462 and b is equal to 3. Substituting in the formula, we get x2 is equal to 2.335. Similarly, we need to calculate f of x2. That becomes a negative value. Consider with the positive, that is f of 349 is a positive value. Therefore, a is equal to 2.2335 and b is equal to 3. Substituting in x3, we get x3 value becomes 2.3645. So repeating this process for successive approximations becomes x4 is 2.3770, x5 2.3779. So correct to 3 decimal places to get 2.378 maybe. So here 2.377 we have taken. So that is all about the regular